Hi everyone. This is UCL Artificial Intelligence Society, and welcome. My name's Joy. I'm the head of content here, and today we have a very special guest. We have Piotr, who is going to give a quick presentation about his PhD and his work research. So, do you want to introduce yourself?
Sure. Hi. Thanks for having me. I hope I won't bore you with what I'm doing. I think it's
Sure
pretty,
not.
uh, pretty interesting and exciting, especially when we talk about applying artificial intelligence solutions to finance. Regarding introductions, let me just, yeah. So briefly, I'm currently a part-time PhD candidate in computer science at UCL. Although my actually bachelor's and master's is in economics and finance, so I'm sort of like a hybrid. Hence, yeah, applying machine learning to finance, which is like a perfect symbiosis, I guess. Apart from that, I'm a CFA charter holder since 2019. That's pretty much it regarding my education. Work-wise, I'm currently a senior quant at Church Commissioners for England, and I know it sounds a bit odd, but in fact, we kind of start to getting more complex with modern quantitative analysis in the church. So it's pretty exciting. Generally, Church Commissioners for England is an endowment fund. It's one of the wealthiest charitable organizations in the world. Currently, around $10 billion in assets under management, and yeah, we are not just helping the church; we also help other institutions. So we like distribute, donate institutions in need. So there is a double responsibility. So not only we have to actually make money, but we also, a lot of people rely on us. So we have to be super careful. Previously, I was a senior quant in a research firm that was in Poland, but I had an opportunity to work with one of the largest US investment bank, both in London and New York, where I pretty much learned all the stuff that I'm doing nowadays. Yeah, apart from that, I'm a mentor for students or even my colleagues, whoever is in fact interested in financial machine learning, would like to make these first steps, because especially students, I work with some brilliant mathematicians, way smarter than me, but they have no idea about machine learning or just machine learning finance. So I'm happy to help them. And privately, yeah, like I mentioned, worked in Poland because I was born and raised in Poland. I currently reside in London with my family. I have two little girls, and thank God Boris Johnson did not close kindergartens. No, so that actually we can have this conversation in peace, because my wife took the younger daughter away and the other is in kindergarten. And my interests, apart from finance and AI, I really like video games, single player video games, generally computers, but also I'm passionate about astronomy, history, and football. So yeah, that's pretty much about me. I'm happy to actually share, uh, a bit depends if a bit or not, but about my PhD first, which is actually focused on detecting and predicting regime switches in finance.
Yeah. So, for those who are actually not very knowledgeable in finance, could you briefly explain what a financial regime is, and especially why it's important with regards to machine learning?
Sure. So financial regime is like a super significant component of financial time, not only financial time series, of time series. It's just the thing is that whatever time series it is, in this case finance, it has some periods that actually differ with each other in asset returns, volatility, and correlations. In fact, you can even see on the chart here, where I use model I'll talk about in a second, which shows you these regimes. In this case, we have low variance regime and high variance. So it's clear, let's say low variance regime is this kind of a calm, ever rising, slowly growing regime where pretty much everyone is happy. Assets generate higher returns. They are a bit less correlated with each other. Whereas the red is where pretty much everything goes bust. People panic. At least in this picture, people panic. Returns are low. Volatility skyrockets. And actually, asset correlation is getting higher because during these periods, if investors sell, they literally sell everything, and sometimes they even just want cash, like in fact happened lately in March 2020. And from not only machine learning perspective, but from asset management perspective, they are important to actually detect, to even predict, so that you, an asset manager, whoever that is able to adjust portfolio weights and be ready for them. So say, well, if you're kind of in the beginning of the green period here, obviously you would like to move a lot of stuff, your money, to more risky assets because they tend to make you more money. But when you're getting closer to the peak, you would like to actually move back from risky asset to so-called safe havens, such as some developed countries bonds or gold, or even some currencies like Japanese yen, Swiss franc, because they kind of have this money parking effect, or you just do not lose that much. Sometimes you even earn money where everything else goes down. And hence, this is super important, because if you don't care and you just follow, sometimes even you follow those classic portfolio theories, you may in fact lose more than you should. And generally, this regime switching area of research is has been getting more and more attention since 90s, pretty much.
Okay,
And yeah, this is what I
so
like to study. Yeah.
that's really cool. So just as a concrete example, I can see on the graph like the 2008 financial crisis, like it goes into very high variance. So would that be an example of when machine learning would have been really beneficial to kind of, I guess, reduce the losses that most people suffered throughout that crisis?
So as long as it's set on sort of predicting it, this is what I want to do, because generally what we have now in research are these amazing models. They are called Markov switching regressions. It's melody of the 70s even. And they've been really solid regarding detecting those. So pretty much they say, what's the probability of certain state, whether low variance or high variance, being persistent over next step. But they pretty much tell you like the current situation. This is sort of nowcasting. And what I want to do is to actually predict them ahead. So to put it into example, Markov switching regression here would tell me, right, all right, we're in red. That's cool, but everyone knows it. I mean, so it's better if somebody would tell me here that we're heading into red. And this is what machine learning can help you with, because obviously you want to predict something with these models in advance, something that Markov switching regression, for instance, is not capable of in the same magnitude. And that's why it's super useful, but then again, super difficult.
Yeah, I guess whoever manages to do it will be really rich.
Yeah, well, generally this is how it works in finance. Whoever has a model that works generates high risk-adjusted returns, and everything is fine. But you have to be really careful, and I'm glad to talk about it a bit later.
Yeah.
But just to for instance, put it into example, recently this red period we had in March 2020, COVID, right? Slump where was the fastest bear market ever, and markets were losing double-digit percentage points every day, and this situation was obviously super difficult for any machine learning model to predict, because which model can incorporate coronavirus? I mean, so that's why it's sometimes it's not actually. That's why I mentioned it's difficult to capture everything. But hopefully, I'll with my research I'll be able to figure something out. So yeah, the thing what I'm showing you here on these two slides is actually my first experiment. So this is more still this classic quant analysis, because what I'm doing is enhancing Markov switching regression model, something that a lot of researchers have done. However, in fact, I'm using technical analysis to help myself. And generally, academics do not really like technical analysis. But in the industry, it is used all the time, and a lot of people, institutions, find value in it, especially when you blend it, well, use it as a factor in machine learning models. So I wanted to enhance those. Even when you look at this chart here, this two-state Markov switching regression, so just low variance, high variance model with technical analysis, so that I would actually be more accurate regarding onset of every regime and smoother. Because if you even take a look at dot-com bubble here, Markov switching regression told me that, all right, we were in red, but then we are in green again, red, green, red. This is obviously, I don't know, from some short-term trading perspective, could be even maybe useful, but from long-term perspective, like what we have in the church, we would rather the model to say it's red all the time, and somewhere around here you would tell, all right, it's green, let's buy. And here it says it's just red, not any green, red, and then here again green, etc. That's why actually these enhancement to Markov switching regression popped up, such as three-state models, which would capture the medium variance. So whatever the two-state is not sure of, because I bet somewhere around here, during the dot-com bubble, the green periods, the probability was possibly around 51%, which is obviously like a toss of a coin almost. And that's why those medium variance, which is added, could be treated as some sort of an error. So you disregard the medium variance because the model is not sure of it, and you leave with just green and red periods. This is where the model says, yeah, it's green for sure at 90% probability. But as you can see from this chart, it's pure mass. You have green, yellow, red, yellow. From practical standpoint, nobody would like to look at this model. And actually, even the papers I use say the same story. It's like three-state models are not very stable. However, I can spoiler a bit here now. I found that in those three-state models are actually doing a pretty good job with commodity futures. So that's worth exploring in the future. So what I wanted to do is to actually, I want to sort of smooth things out with this model. And I just added, well, not maybe just, I added this technical overlay. It's called Kaufman's adapting moving average, which blends volatility and trend component. And thanks to that, I was able to discern actually 4 states, which are also pretty helpful, because what this model, for instance, doesn't show you are the transition regimes. So if we're in red, right, we're in red, great, everything panics, let's just wait it out. However, when will it stop? Or if it's rising, when things are about to get a bit shaky, let's say. So those 4 state models, well, the one that I constructed here, does it. So it for instance added this yellow bullish high variance regime. For instance, you can see it here because the markets have risen enough, and here investors were a bit, I don't know, the models, the volatility started rising a bit, but it was from technical perspective still bullish. But here he had this warning signal that, all right, people may actually start to panic a bit. And indeed, like peaking is usually about this. People are not sure what to do next. And later, right, we had a slump. And then it rose again. Same with bearish low variance, right? So when everything stops panicking, like it's barely visible. But for instance, like here after January 2018, variance start to go down, people calm themselves, and then the markets rise again. So this is my kind of way to address this problem. But yeah, as you can see here, it's still pretty classic quant stuff. However, I need all that to generate labels for the machine learning algorithm that will be in the next experiment. Because if I want to predict something, I need obviously Y variable, which in this case are classes of bullish high variance, bullish low variance, bearish high variance, bearish low variance. And obviously these classes need to be accurate because it's not and smooth. Because it's not even without it, like you cannot just do it manually. When do you know when things started or ended? And that's why you need these helpers. And this model maybe would be helpful, but it's not that good as this one. So yeah, this is what I did, and now I'm heading into machine learning.
Yeah, okay. So like now that you have the input for your model, speaking of which, are there any like standard machine learning models that are commonly used in the world of finance that you might consider using as well?
Yeah, sure. So generally from what I do or read about, you have these three, let's call it, or no, it's even four, big, say, specification methods that are used in finance. So you have this common supervised learning, complex, I call it, I'm going to explain later, complex supervised learning, unsupervised learning, and reinforcement learning. And common supervised learning is what I call it, that's just my names. Are you see three, maybe four models, algorithms such as random forest, extreme gradient booster, and support vector machine. And pretty much whatever paper you read, book, authors are either praise one or the other. And well, there's pretty much this no free lunch theory, which says no model is best for everything. That's why you need to juggle. Sometimes random forest will be best, sometimes XGB. I find XGB to be the best, but that's myself, because one of the best, if not the best book on the market on financial machine learning is all about random forest. So honestly, it depends. Then you have this complex supervised learning, which are neural networks. And these are mostly used for asset portfolio optimization. Usually like feed forward because it's a bit easier. The architecture is a bit easier and can handle relatively smaller sample sizes. So for instance, it's not like you have million observations. You may have tens of thousands, for instance, or even thousands. And you obviously, if you want to do anything with neural networks, you have to go simple. But sometimes you have more long short-term memory networks are very common in finance. Then you have unsupervised learning, again, for portfolio optimization, such as hierarchical clustering, for instance. And reinforcement learning is, relatively least discovered, because obviously you need like huge sample sizes. But there are some nice, I actually read a book recently that did like this huge chapter on reinforcement learning. How can that be applied in finance? And it's pretty interesting, and it's pretty good area to I guess, to explore, because you pretty much have like an agent, like an AI that does the trading for you and learns from it. But yeah, that's actually not that simple to implement.
Yeah.
So
What would you
these,
think?
yeah.
Sorry, what would you think is like the most difficult aspect of trying to implement machine learning, um, in specifically in finance? Would it be like getting enough data or things like that?
Yeah, data. Honestly,
Okay.
that's it. Because even when it comes to say image recognition, text recognition, you just type Google repository text or image database, you download 10 gigabytes of data, and then you just fine tune your model, which you, especially when it comes to text, you already have transformers that are pre-fit, and you just apply it to your data and you end up with 99% out of sample accuracy. Well, in finance, you have to deal with it yourself. Some you just don't have it. Either you have to buy it from data providers like Bloomberg, DataStream, FactSet, if you really want to have a good model, or some, for instance, banks, hedge funds, they tap into some alternative data sets, like when some like real-time trading stuff, credit card usage. So they obviously end up with huge databases they can apply their models for, but that still obviously requires a lot of, say, cleaning and all that
Mm,
process. But I guess it's just the data is a real problem,
okay.
especially because you have a limited history. So if you want to have a model that kind of tries to see everything and keeps in memory whatever happened from at least 90s, obviously you have a limited history to the 90s, right? So it's not that you can although that's another story I wanted to say. It's not that you can synthetically generate it, but actually that's kind of a new area of research that may allow it. But that's generally is the issue, and that's the issue for me as well.
Okay.
And if I may, sometimes even I guess you know that certain factor could be important, especially if you do emerging markets. You want to predict emerging markets. But the thing is that certain data that, even from like industry perspective, the expert perspective, you know, it works, but actually it started to show up, to pop up, to be published since 2005 or 6. Like usually you have these China macro readings that obviously affect it, but they are since 2004 or 5, and you kind of have to, lose a lot of years of data to do anything. And that's I guess that's also another. So, but yeah, still data.